The only way of finding the limits of possible is by going beyond them into impossible. A very good evening to one and all present here. It gives me immense pleasure to welcome you all to the seventh webinar conducted by IGS Student Chapter Marine Engineering College on the topic Underground Caverns by Mr. Pravin Muley, Tunnel Engineer, ARCADIS, Singapore. The webinar will commence shortly. Before that, let me brief in certain instructions for the attendees of the webinar. All participants are requested to mute their microphones and switch off their cameras during the session. All your doubts and queries will be cleared at the end of the session. Please feel free to unmute yourself and speak or post it in the chat box. At the end of the session, a feedback form link will be provided in the chat box, which is to be filled in without any fail, as certificate will be initiated based on this. Now, I would like to call upon Steffi Mary Simon from MTech to formally welcome our respected speaker.
Hello, is I'm audible? Hello, am I audible?
Yes.
Yes.
Hello everyone and welcome to this section. The task of introducing the speaker is a great privilege. I would like to introduce today's speaker, Mr. Pravin Muley. Pravin Muley graduated with a Bachelor in Civil Engineering from MIT in 1998 and did his Master's in Civil Structure Engineering from MIT in 2001. More than 11 years of experience in the NATM tunneling, he specializes in sprayed concrete lining design and supervision of NATM tunneling with his prestigious work as a consultant to the Jurong Rock Cavern when he was a project officer with the Nanyang Technological University of Singapore. Some of the projects that was completed successfully under his supervision were the Jurong Rock Cavern, Deep Tunnel, and Sewage System DTSS-2. Currently, he is working as an SCL designer representative for the DTSS2-T07 project. Sir, it is a great honor to hear from you this evening, and I truly believe that your experience can inspire young mind here today. Sir, on behalf of all present here today, I welcome you to this section.
Okay, thank you. Let me share my screen. Okay, can you see my screen?
Yes, sir.
Yeah, respected professors, teachers, and my dear fellow students. Thank you very much for inviting me for this presentation on the rock caverns. For this today's webinar arranged by your college, Marine Engineering, with the IGS Student Chapter. So let's dive into this exciting Jurong Rock Cavern presentation. Okay, so basically you are seeing on the screen is nothing but a shaft, which is around 30 meter in diameter and around 130 meters deep. So this is for one of the Jurong Rock Cavern shafts. I think I cannot move on my screen. Okay. So the brief overview of my presentation will be, I will introduce you with the underground structures which are used in the urban areas and in the remote areas. Then I will introduce you with the cavern. You may be knowing much about the tunnels as you day-to-day activities we come across these structures. Then I will tell you what is the difference between the tunnel and the caverns. And we will see what are the different types of caverns, or rather we will see the uses of the cavern projects for the different purposes. Then I will tell you briefly the excavation sequence of the caverns. It is bit similar to the tunnels, but at certain stages it is bit specific also. Then I will deal with you with the cavern construction, how it is being done. So if you see the urban structures, we mostly see this housing above ground. If you see the working areas like offices and stores, they are also above ground, and some just below the ground, like basement 1 or basement 2. Mostly in India, we don't go deeper into the underground, as uh, we have enough land for the horizontal growth. But for some countries like Singapore, which doesn't have a lot of land, it is just an island, city island. Uh, so it becomes very difficult for horizontal expansion of the country. So in that aspect, we need to go for the underground. So for the public uses, we can definitely go for the underground, like stores, then recreation centers, then the like MRT stations, or the we can say uh, metro stations, etc. That we can bring it into underground and freeing up some spaces. Currently, we don't have the housings which is underground, but maybe in future for the metro cities, we may need to go for the underground housings. Then for the industries, we can bring down those industries well deep into the ground. If we say this has 10 meters, 20, 30, 40 meters, we can go deeper as far as the industries are concerned. Because in the industries, we mm, work 8 or 10 hours. Housing, we live psychologically whole day. So we need to get the free air and light, that is okay. But for the industries, like for the storage production facilities, then industrial spaces, we can go deeper down into this one. So here we come into here comes this caverns. So we can make use of the caverns for these facilities to be taken down. Then for the traffic tunnels and then parking, etc., we can still go down for the urban infrastructures. Of course, for the technical infrastructures like multi-purpose tunnels, which is used for the storage, then fuel storage, power generations, and water treatment plants, those definitely we can go down below ground much deeper. So let's see in respect to a couple of major cities in the world, which how they use the different facilities underground. So let's take an example of the New York City. If you see the New York, then in India, we see the power supply, that is electrical powers. We have some poles and then the wires running across the roads and around the roads and distributing to the houses. But in the mega cities, metro cities, like maybe in Mumbai, Bangalore, etc., also, we have this power uh, underground. So we don't see the wires anywhere above the ground. Then we have the other facilities like cables. Nowadays, our life depends on the mobiles, data, means the internet. So this is transferred to the cables. Carrying it above ground is very risky. So they put the facilities underground. Then the water distribution system is also underground. Then if there is some storm, then for quickly deflooding these areas, some pocket areas, they can have the stormwater drains. Then gas pipelines is provided to each and every households by using the pipes instead of providing the gas cylinders and all these things. This makes the life very efficient by providing this one. Then we have these metro stations, MRT stations, or we can say subway stations for the transportation. So if you go again deeper, then you have this sewerage system, which transports the um, sewer water to the water treatment plant. And if you still go deeper, then we have this deep water, which is having the maybe around 2 meter diameter water pipelines, which can distribute to suburbs. Then if you go for the cities like Singapore, you can see this. This is the vertical structure for only small area. We can accommodate so many facilities. For example, there's bus stations. We can here in Singapore they call it as a bus interchange. So bus stations they can be directly under the building. So if you have the 15 or 20 story buildings, they can have the bus stations under that one, and then the bus can ply. So also these pedestrian links, if you're going across the roads from one building to another building, then you can have these pedestrian links. Then as you go deeper, we have these different facilities. This is you can see here. This is a common tunnel which has the water pipeline, gas line, sewer line, etc. So these are being constructed under the ground. Now, if you see this one, this is the air condition pipelines. This is new things that you will come across. That the entire building is provided with the aircon, and that aircon is been connected with these pipes, and this why pipes will carry the chilled water, and it will have the building to cool down. Then we have this MRT, means under subways. Then we have the roads. If you go deeper, this is the deep tunnel sewerage system. So now Singapore is planning to increase the population in the next 10 years. So for that one, they are developing these facilities. So currently I'm working on one of the projects that is deep tunnel sewerage system. So this is around 6-meter diameter tunnel. Inside diameter is 6 meter, which carries the wastewater from the households, and it goes to the treatment plant. And then from that one, after the water is treated, it is sent to the sea, deep into the sea, or it will be sent into some lakes. Then these are the Jurong rock caverns for storing the hydrocarbons like oil and gas, naphtha, etc. And below that ground level, again, this level is around 130 meter below the ground, if you see. And this one is half under the water and half under the land. This Jurong rock caverns. And this is the ammunition storage facilities, which are still deeper, around 160 meter. And Singapore is again planning for the caverns which can store the water. If you see the Singapore, it is if you can see there are very heavy rains. Every week you will find the rain throughout the year, but Singapore doesn't have the capacity to store the water, so they have to buy the water from Malaysia. Malaysia is just across the strait, maybe around 5 kilometer distance between Singapore and Malaysia, or causeway 120 meters. So from the Johor province of the Malaysia, there is one river, and from the river they have constructed, Singapore has constructed a dam, and they are bringing the water to Singapore. So it's an expensive affair. So Singapore is planning for the underground caverns which can store the water. So some research is going on onto this rock caverns which can store the water. But the hills, Singapore government is undertaking. This is subsea tunnel for the Tuas water reclamation plant. So we'll be doing some projects like that also. So that will be interesting. So this is a simple definition of the tunnels. I think everybody is knowing. Then depends on the geology. We design the tunnels, different sections, different faults, different geology, and then we design the tunnels. The tunnels can have the different shapes, and the purpose of the tunnels can be for the use of highways, railways, sewerage system, water supply, etc. So if you see the tunnel, we have the different shapes. Most optimum shape is the circular. As far as the civil engineer or geotechnical engineer is concerned, this is the safest shape of the tunnel. But the economical will be horseshoe for the trains and the routes, the horseshoe is the most economical. And for the cross passages or something between the two tunnels, generally we go for the elliptical section. If you go for the circular section, then we need to do more excavation, and the contractor does not like to have extra excavation, which will cost them more. So they adopt the different sections. So here from this one, you can see this one is the Budapest tunnel in the Hungary. Um, so it is the elliptical shape. You can see this Williamson tunnel, which can be egg-shaped. These are the old tunnels. Then this is one of the advanced tunnels in the Alps in Switzerland. This is the Gotthard tunnel. As a geotechnical engineer or civil engineer or any tunnel engineer, you will definitely come across these tunnels, or rather we should study these tunnels because those are constructed in the very difficult geology. Then we have this new tunneling systems like TBM tunnels, which are easy and faster way to do the tunneling. So generally for this TBM tunneling, 95% of the tunnels are used using this circular tunneling machine. So that is the tunnel boring machine. But now with the advancement of the technology, we have the rectangular tunnel boring machine. So there are some projects we come across in Singapore that use this tunnel boring machine. This box type of cross section is used generally for the cut and cover section, cut and cover tunnels. Okay, now let's go to the caverns. So cavern is generally is a cave, okay, or a large chamber. And these rock caverns are, there are some natural caverns, we know it, but for the purpose of our um, use, we go for the mine caverns. So these mine caverns are conventional caverns, conventionally mined caverns by using the conventional mining techniques such as the uh, such as drill and blast or NATM method, etc. And it consists of the shafts, ramps, drifts, uh, and forming this cavity, which is we call it as a cavern in the solid deep rock. For example, a granite in India, we can say basalt, which is also good stone, good geology, and yeah, and we use it for the different storage purposes. Here I can, for the caverns, I can tell you some of the terminologies. This is the crown of the cavern, this one. This is the invert, okay? And when you start the cavern or tunnel at the hill, that is a portal. First cross section is the portal. Then this is the, if the size of this cavern is very big, then you cannot excavate the full face. Then we have to excavate in sections. So we can call this one as a top heading, and then we subsequently have the benches, and we can say this one as a bottom. If this one is again big, then we cut it into the different smaller sections, and then this portion is a drift, which can have the horizontal excavation. Now the spring line, this is very important when you go for the design of these caverns. This is a spring line. When this one is sloping outward here, and you see this one is sloping inside. So this junction line here is a spring line. Okay, so these are the some terminologies that we use. So this cavern can be of these shapes as well as this one also. This is a Jurong Rock cavern, which is excavated in top heading and benching. This is another Science City project in Singapore. So we are planning to have this one different headings and benches. So this is a top heading and benches. So here, if you see this Jurong Rock Cavern, here is a 20-meter wide and almost 27-meter in height. So it is as good as a 10-story building. So this is a huge cross section, and it runs around 340 meter long. Okay, so this is the slash or drift, we can say. This is the heading, then we can have the benching. So different ways of excavation. Now, what are the benefits of this cavern structure? So some of the benefits for the community regarding the placing facilities in rock caverns are tangible and some intangible. So intangible, like removal of incompatible land uses from the local community. Incompatible means suppose there is in the metro city there is one company, because the cities are growing, and if there is some factory, okay, or s- or some other facility which we don't need it day to day, or if that company or factory is there, it is making noise and creating the air pollution to the surrounding areas, then what we can do, you can just take out that factory and uh, drill a hole, or that is the shaft, and put that under the cavern, and we can take care of the this air pollution, and we can save some land. We can have the open space, and we can make this some gardens, plant the trees, and then we can reduce some air pollution. If you see the air pollution in the cities like Delhi is very means toxic. It is around 250, 300. It's criminal to be have this air quality, but we don't have any option, so we can use the caverns, put the facilities underground, and then we can reduce the air pollution. We can use the caverns for the parking, and some tunnels connecting to it for reducing the congestion in the traffic, so we can make the traffic faster and the air pollution can be reduced. So in Singapore, we are also planning to have one project that is IGMS. So generally, what happens, the ships comes, and then the cargo is unloaded, and that unloaded cargoes like the containers, they are transported using the trucks from one end of the island to the another end. So it travels around 50 kilometers. To reduce the pollution and to reduce the congestion of the this traffic, Singapore is planning for the underground caverns at different locations, at 4 5 locations, prominent locations, and storing all these containers in those facilities, and they can be transported easily to the nearby locations. So those caverns will be connected by using the tunnels, which will be again underground. So this is called as IGMS, Integrated Goods Moving System. So this will be a very good thing to study, and what if you come across these projects, it will be very interesting to join. Then intangible benefit, like storing the ammunitions and hydrocarbons, etc. Generally we don't use this near the cities, but yeah, of course, there are some ammunitions which are already stored, so we can move it to underground. Hydrocarbons like oil and all these things, facilities can be brought down under the ground, because day to day we don't need it, and we can use the pipes to connect it and get this one. And hydroelectric power generation, if you have some hilly areas, and you can generate the power by using this one, by using the caverns. So these are the some tangible and intangible benefits of the cavern structures. Let's see what are the uses of these structures. Okay, now in the Turkey there are some cities which are underground because of the high heat, or because of the enemies which will be invading their land. The people in the Turkey, they form the underground cities, like for example of Kaimalki. Then if you go for the India, you can see this Ajanta Caves. Most of you have visited this Ajanta and Ellora Caves. The Ajanta Caves were used by Buddhists for the meditation and for living purposes. So this is one of the good examples of using the caverns. So this all these are being carved into the rock. So this we can see as caverns, and they were working as a fantastic homes for them for living. In 2004, during the Winter Olympics, Norway constructed this beautiful Jovik sports hall. This sports hall is very huge. It's 91-meter long and 25 by 60-meter wide, and it has excavated 141 k meter cube of rock to provide this one. So Winter Olympics was held here, and it got a lot of accolades across the world. Yeah, we'll see how the excavation sequence was there for that. Now, sorry. Some other examples for the large caverns is the metro stations in different cities like London or New York. So you can see here. Sorry, I'm getting some call. I'll just mute it first. Okay. So this is the cavern is underneath the Grand Central Terminal, which is it will work as a concourse for this train stations. You can see the 4 trains coming in. So they have dug this tunnel using the tunnel boring machines, and they rested this tunnel boring machines inside this area, because taking out this tunnel boring machines out from this area was very expensive. That's why they dig some area here and buried this TVMs over here. And this is another example of the metro stations in the Moscow, which looks aesthetically very beautiful, and it looks very majestic when you see these Moscow train stations. These are nothing but the caverns. If you see today's world, we are hanging. Also we are connecting through the computers. If you see your laptops, if you work on the laptop for 2-3 hours, we can see that a lot of heat is generated, correct? And if you see these data centers, these are huge, very huge. So the main thing for the data centers to keep this cool as possible, and it becomes very difficult because if you see in India, we have very many seasons like winter, then summer, etc. So the temperature variation is very high. To keep these data centers or these computer labs cool, it becomes very difficult. So if you move this facility underground, then we know that underground facility, it will have the constant ambient temperature. The temperature will not change, the humidity will not change, so it will you will be easy it will be easy for us to maintain this temperature and the humidity inside the caverns. And since the access points are limited, we can control the entry and exit of the for the data center. Again, there will not be any possibility, means the possibility of attack on this data centers will be limited, as it is underground, and it will be difficult for the enemies to throw bombs or rockets, launching the rockets at this one and saving the data, because data today is very, very important. Other thing for the above ground data centers is that the heat waves, then last storms, floods, cyclones, those affect the working of these data centers, and their expenses grow multifold. So in order to save those, we can use these underground structures like caverns. For underground facilities like the science lab, this is neutrino experiments which was conducted in the Atlas cavern. So you must have heard about this neutrino experiments. for which one of the scientists got physics scientist got the a Nobel Award. So this facility is also quite huge. This is just for the physics experiments. So you can see this is around 800 miles. They're shooting this one, and in this cavern, they're collecting these neutrons which are coming from the sun and doing some experiments. Let's not go into that one. But this facility, the caverns, cavern is very complex. So you can see this is the facility over here. This is the cavern, and these are the different shafts. And this is the tunnel, which is used for shooting the neutrons. This is around 27 kilometer long round tunnel for the experiment purposes. So this is a very good example for the tunnels and the cavern these things. We can use these caverns for storing the compressed air or some other gases. There is a special way of excavating these caverns. These caverns are generally 20 meter in diameter and around 300 meters, 2 to 300 depends on the geology, 2 to 300 meters in length. So these are the large caverns which are excavated in the salt formation. So in the salt formation, what they do is they drill the hole here, and then they send the water under pressure, and this salt over here gets melted and it is pumped out by sending the other gases. So this water comes on the surface as a brine, and then they dispose of. And then this area, which is the cavity, and we call it as a cavern, is used for storing the natural gas. So if you can see this, another example of this use of this natural gas or compressed air here, for example, in some countries, the for the electricity consumption, there are different time zones, means peak hours and off-peak hours. If use in the peak hours, then the rate for the electricity consumption will be high. Rate means the amount of money what you are paying is higher than the off-peak period. So what they do from the grid during the off-peak hours, they will use it motor, compress the air, send it to this cavern, and this compressed air is stored here. And then during the peak hours, what they will do, they will just send out this compressed air and generate the electricity and send it back to the grid, so that more electricity will be in the consumption for the people or the companies. Because up till now we have done a lot of research, etc., but we don't have anything which can store the electricity. We can use the capacitors or batteries, but those are not the best way of storing the electricity. Okay, then another thing is for storing the liquefied natural gas. When we bring it, cool down this natural gas at minus 160 degrees, we can store it with the reduced volume of 600 to 1. So means 600 meter cube of gas can be stored into the 1 meter cube area. So this is very strong room or the cavern, which is underground with a very high thickness of the concrete. And this is one of the use of these rock caverns, which we can use it for the storing this LNG storages. Another use is for the oil, naphtha, or the petroleum projects, petroleum products. This is one of the examples which is being constructed for the Jurong Rock Cavern here in Singapore. If you can see here, this is the area which is on the Jurong Island, which is using this above ground storage. Okay, this requires these tanks are almost 20 meter in 15 meter in height and 10 meters in diameter. Generally, these are the sizes over here, and the distance between two is 25 meters, 20 to 25 meters. So it requires a lot of space for storing. Another thing is that there is always an fear of the terrorists. They can attack. Once they attack on this one, once it is blasted here, it can spread all over the island and it can be gone in one hour. Yeah, and major economy of Singapore depends on this oiling. Uh, so what they have done is they have excavated this land under the sea. Okay, so here is the Jurong Rock Caverns. So it is clearing this area around 60 hectares of the land. So all the facilities will be going down under the sea over here. So they can clear the area. The safety is enhanced, and then no issues. We can have the couple of control points from the access shaft here, and this is access shaft over here. So we have only two control points, which if you control, then you control everything. Here, controlling this entire sea is very difficult. Yeah, and this rock cavern is 20 meter wide and around 27 meter deep. This is me over here. Maybe it's very dark here there, and then you cannot see it. So it's around 126 meter below the ground. So it's quite deep over here. I was somewhere here in the yeah. So these are the caverns. 1, 2, 3, 4, 5. This yellow are the caverns. The blue one over here are the water curtain galleries, which this is the unlined caverns, and we have around 50 to 100 thick shotcrete onto this one. So whatever the oil is there, that can leak through this one because it is not proof or resistant to the oil. So it can, through the cracks, it can go up. But these water curtain galleries, with the pressure, they can maintain this one, and then they can keep this into this enclosed area. So these water curtain galleries are important over here. So this maroon color or magenta color, you can see this is the access shaft. Access tunnel, and these are the shafts over here. I've shown you the picture. So this is the picture of the access shaft. So here on this side is the land. On another side is the land. Of course, that is also a backfilled land by Singapore. And then this is a sea in between. So this area is under sea. So water pressure is also acting over here. Water curtain galleries, they are putting also pressure, and that's why this is contained. Then another use of the rock caverns is for the power generation. So generally this is 25 meter wide, and this is around 50 to 60 meter in height. So this is one of the examples in Oma Oya in Sri Lanka for the hydroelectric power generation. They are doing the basement for this turbines over here. So this turbine facilities will be over here. If you can see this in Linth power plant, this already constructed. Inside is these turbines, which will be connected to the penstocks. Yeah. So this is another example. Now let's go to the excavation sequence. Because the caverns are huge structures, the geology varies from meter to meter. So it is not possible for us to excavate this full face over here. If this is 30 meter and this is 20 meter, so you cannot have the equipment which are capable of reaching to this height and excavating it. So what is the best way is to have different benches. So top heading over here, and then we have the benches. Okay, so in that one also, if you are not sure about the geology, generally these rock caverns are placed based on the geology. We drill the boreholes, and based on the boreholes, the geotechnical engineer, geologist, and the other design team, they will decide whether we want to go for the rock caverns in this location or not, because excavation is very big issue. Another thing is that if the faults are present in that location, then it is very difficult for the excavation. Even after the excavation, if the faults are active, then it becomes difficult. The cavern will not be stable. So based on the judgment from the geologist and the geotechnical engineers, the location is uh, fixed. And after that, still we cannot go for the full top heading. Then in that case, we can go for the pilot tunnel or the center heading, and then we can have the slash. Sorry, the slashes. So here we can go for the excavation in the front direction, and then the excavation in this horizontal direction to make this shape. And then we go for the bench. In this one, we can drill the holes from the top and put the explosives to go for the this benching. So depends on the geology and depends on the use. The design team will decide which type of excavation sequence we want. So here for this power generation project, for example, they're using these different excavation sequences. Let's say this is the side one, pilot tunnels here, one number, then this two, and then this middle section 3, then the 4, and then this arch 5, then 6, 7, 8, 9, 10. There can be many excavation sequences depending on the geology. This after every excavation, the geologist needs to go there and then find out the what is the phase of the rock. Well, what is the geology? So for that they use Q system, Barton's Q system, to know quality of the rock, and depending on that they will decide next excavation sequence. So here's another example for the powerhouse, which has a different excavation sequence. So this is one cavern, this is another cavern, and this is the third cavern. So either we can start the excavation at the same time, we can start the excavation one after another, like you excavate this one, then you excavate this one, and then you go for this one, something like this. So that one also decided beforehand, and then this is the excavation sequence over here. For another thing for deciding this excavation, apart from the geology, is the logistics. How many number of drill jumbos you have, how many trucks for mucking the material you have, how many manpower you have. All these factors comes into account, not only the geology, so to decide this excavation sequence. And also what is the duration of the project, that also plays important role. If you want to complete the project earlier, then we need to have many shifts, many manpower, and the number of sets of equipment. This is the Jovic mountain sports that I've shown it to you earlier, which was used for the Winter Olympics. So this is the excavation sequence for this one. So this is number 1, 2, then 3, 4, and then this is middle portion 5, etc. So once you decide the geometry of the cavern, then we go for the boreholes. We go for the boreholes and we find the geology. And based on the geology, we use software to create a model. We carry out the numerical analysis. The softwares can be Plaxis, UDIG, 3dig, NIT, NMM, RS2, RS3, Unwage, etc. There are the different softwares which are available in the market. So you choose based on the which is available in your company, or maybe which your company can afford. So we carry out the analysis, and we see which are the spots where the stresses are higher. So the stress where the stresses are higher, we provide the reinforcement in the form of the rock bolts. Okay, so these are the rock bolts. In the vertical direction, we provide the rock bolts also here, or from we run a gallery over here, and we have this cables, and which are tied here with the tension, so as to keep this roof in position. Yeah, because once you excavate this one and your turbines are here, and if this rock falls, then it will damage the infrastructure, which is very expensive. The turbines or the transformers, which transformers over here will be very expensive. The cost of construction of this cavern is just 20% of the cost of the project. So this providing this reinforcement, extra reinforcement, will not cost much. So this is another example of fine mesh generation over here for the numerical analysis. This is what we have carried out for the Jurong Rock Cavern. Okay. Then we have to propose some monitoring for the cavern roofs, cavern walls. When I was in NTU, I worked on the monitoring for this Jurong Rock Caverns and some other facilities also. I've developed the fiber optic cables, which is capable of monitoring the entire cavern. So for the convergence monitoring, we use this fiber optic sensors, which we have developed in association with the Omnisense company in the Switzerland, and Bruck Cables, which is also in the Switzerland. So we had the collaboration and we developed this one, and we have applied this one to the Jurong Rock Cavern project for the monitoring. Okay, now how the excavation is done. For the tunnels, we can go for by using the drill and blast, or the NATM, or maybe the tunnel boring machine. Best is tunnel boring machine. The geology doesn't matter. We just go from one end to another. We have to need to adjust some of the parameters, and we can easily do the tunneling using the tunnel boring machine. But here the size is enormous. We don't have the tunnel boring machine which can excavate the caverns. So the procedure is to do the survey. You do the survey, you mark the cross section of the cavern which you want to excavate, mark the places where you want to put the loads. Loads means your explosives. So you drill the holes on the points where you're going to where you have drilling team, where your blasting team has given you the plan. So accordingly, we will drill the holes, and then the blasting team will come, and then they will load the explosives based on the design. The design will vary based on the cross section, and the blasting team is expertised in designing the base pattern for the maximum output of the this rocks. Okay, so after it is loaded, it is evacuated, and then this will be blasted. After the blasting, a lot of gases will be there, in which we cannot go for an hour or two. This is the ventilation pipe, which is generally minimum 1 meter in diameter. So this will be exhausting, inputting the air over here. So after some time, this toxic air will go away, and then your team can go over there and do this dislodging. Dislodging of this one is nothing but the mucking. So clearing of this debris over here from here. So you can have the trolleys, trains, or these muckers for mucking this this area, means clearing this face. After that, your scaling team will come, and then they will see whether on the roof there is any loose rocks or something. Then they will just clear off. And after that, we will see according to the design what is the rock bolts. So depending on the spacing, then this uh, rock bolting team will come, and then they will install this soil nails, or we can say the rock bolts or face towels, etc. In those respective areas. And after that, this is the cycle. This cycle is completed, then another cycle will come into question. Generally, this entire cycle takes around 8 to 10 hours for advance of 2 meters. So for this rock bolts, the rock bolts are designed based on this Q chart, which is developed by the scientist Barton, based on the experiences from around 200 plus sites. So depending on the poor to exceptionally good rock, and depending on the RQD values and this number of joints and all these factors, we find out the Q value. And for the given Q value, we will see what is the thickness of the shortcut which is required, depending on the span and ESR ratio. Generally, this excavation support ratio, ESR, is 1 for the rock caverns or hydrocarbon projects. When the project is of very high importance, such as storage of ammunition, then this ESR we can reduce it to 0.5. If the caverns are for let us say storage of just goods, then this ESR we can improve it to 1.5 so that the design will be economical. So depending on these zones, suppose your Q value comes to be 4, I think this RQD rock quality designation, how we get this RQD is we drill the borehole. When you're drilling the borehole, we take the sample of 1 meter of rock, and we take out and we examine it. When we examine, we see the how many more than 10 centimeter of the sample is there. So if it is 80 centimeter, then you can consider this RQD value from 0 to 100. Generally, minimum is 20 plus 20 to 100. So I forgot to add this RQD, how to calculate over here. So when you go for the face mapping, we mark 1 meter square, 1 meter by 1 meter square, and then we find out this water ingress, then this GR values, then JA, depending on the smoothness of this one, and this SF or stress reduction factor, etc. For the Q, if you go for the Q system from the NGI, you will find all these parameters. So the different tables are there. You can choose these values from there. And this RKD value, either you get it from the borehole or you can measure it on the site also. So depending on this one, you can find this, what is the thickness of this shortcut required, and what is the row of bolts which are required. So here is given to you what is the this support for the support categories. One is where the rock is competent, very good, we don't need any support, and this is the area where the rock will fail. Okay, and in between you can have the rock shortcut lining thickness, and then you can have the rock bolt spacing also. Plus there are some formulas which are available, which you can use it for the rock bolts, design of the rock bolts. I will not go into the details of this one. I'll show you the some reinforcement which are being used for the cavern projects. So you can see this is the exploration gallery, and this is the cavern roof, and these are the cables. Okay, these are the cables which are used for holding this into the position. This is the reinforcement. So some cables are here. Sometimes we use the rock bolts over here. Rock bolts you can see here with the different spacing. So, and this is the wire mesh we use. Generally, we use 10 millimeter diameter, 100 to 100 spacing wire mesh. Or sometimes in the this walls we can use the SFRC, fiber reinforced shotcrete, which nowadays is a trend. So you can see these are the rock bolts over here, etc. So this is the end of my short presentation. Okay, so this is the Jurong Island over here. This is the Jurong Rock Cavern project. This is the phase 1, and this is the phase 2, which will be going on. This is the underwater project, and this shaft 3 is here, shaft 1 is here. Okay, so thank you very much. I will open this forum for the question and answers now.
Thank you so much, sir, for the wonderful and informative session. Now, the platform is open for your doubts and queries. If anyone has any doubts or queries, please post it in the chat box or feel free to unmute yourself and speak out. Anyone?
Sir, hello.
Yes, yes.
Can you share with us any challenging moment you encountered during any of your project?
Oh, challenging. While I was giving you the presentation, there were calls coming from the contractor. So challenging is every time challenging. If nothing is challenging, then these projects will not work. Especially this, the geology. When we were doing this project, Jurong Rock Cavern, do I have any slide for the Jurong Rock Cavern? Yes, here. At this location somewhere, we had very high water ingress, which we didn't foresee. Our numerical analysis was saying that water ingress is well within the limit. Our shortcut lining can take care of it. But when we have excavated this water bearing zone, it started flooding in. And especially since this project is underwater, this project is partially under sea. It was very difficult to contain the water. So let me take, just. Okay, so here you can see this is a sea, and somewhere we encountered the water over here, and there was no possibility for us to stop the water. We called in the experts. We tried our best to do the grouting from the horizontal direction, vertical direction, from the top, but we couldn't contain this water. We even called the experts from the Europe, from America, but then we couldn't do this one. So we have to change this edit. That was not exactly the cavern location, but the edit tunnel, which was going to the cavern. So we need to keep that area in the abeyance. We have to fill it back, and then we have to find out other way of doing this one. Other way for the edit to go to the rock cavern. So that was very challenging and time consuming, and it was very expensive thing that we have learned. Now today we are doing this DTSS2, that is deep tunnel and sewerage system. So they are doing that tunneling, and during this tunneling, in Singapore we do not allow the CHI, means cutter head intervention, where we stop the TBM and check the TBM cutters and all. If required, we have to replace it. We don't allow them to do it in the mixed ground conditions, because in Singapore the soil condition is not good. But contractor suddenly stopped there and in the mixed phase, and we have to every day we have to give the report to the government agency what is happening. If there is cutter head intervention, means you are stopping the TBM, which is under 50-meter ground, and it can cause the surface settlements. And if the building settles, or if there is any issue, then that will cost millions of dollars to the owner of this project, which is PUB, Public Utility Board, which is also a government agency. So this is now challenging because government doesn't allow, but contract has already stopped. And for one tunnel boring machine, they are having 46 cutters, and in one day they cannot change more than 3, because tunnel boring machine is already under pressure, phase pressure. And for going to this phase pressure of around 5 bars, or let us say 3 bar, for example, the geologist or the workers, they have to go into the compression chamber, and that has to be reduced from the pressure has to go from this atmosphere pressure to 3 bar pressure, with half bar pressure in every half hour. So it takes 2 to 3 hours for him to get compressed, accustom his body with the pressure, and then he will go to the TBM chamber. He will do the work and then come back. And again, decompression will take another 2-3 hours. So it is a time-consuming process. So this is again a challenging thing which we come across when we are doing such projects. Yeah.
Hello. Are there any other doubts? Am I audible?
Yes.
Sir, it was a very informative webinar for us. The concepts and the material presented will most definitely be incorporated into our resources. This webinar gives us an overall overview about the topic in a simple manner. It was very useful, very clear and understandable. Also was a wonderful experience for each one of us. Thank you, sir.
Yeah, thank you.
Any other feedbacks? Anyone?
Good evening, all. The topic underground cavern was well explained by our resource person, Pravin sir, and I am really delighted to be a part of this webinar. Thank you, sir, for your great talk.
Yeah, thank you.
Sir, it's a great honor to hear from you. The section was very informative, sir. In this short time span, you have provided us with immense knowledge on the ideas and on cavern construction. Thank you so much, sir.
Yeah, thank you.
Narayan sir, are you there? Head of the department, Dr. Narayan sir?
Yes, I'm there.
Hello, sir.
Yeah. Sir,
can you hear? Yeah. I think
Pravin sir.
Yes.
Pravin sir, this is Dr. Narayan. He is the head of the Department of Marine Engineering College.
Hello, sir.
I'm introducing you to you.
Yeah, it was very nice listening to you. Actually, we have been hearing about a lot of tunnels in India, like along the western coast.
Yes.
Actually, the railway has so many tunnels on that. So from what I hear, the soil is very difficult in those regions, and the tunneling was difficult. Then we have the Atal tunnel, the Kudiran tunnel, but
Yes.
all of these are small, simple tunnels compared to the caverns you have explained here. Very nice. I had the good fortune to see one cavern in Korea that is part of the rail network, underground rail network.
Okay.
The caverns were beautiful places with lot of decorations, colorful trees, and places for people to eat and have refreshments. A very nice experience. But I was thinking about that when you were explaining all these things.
Oh, yeah.
It was very nice. It was very nice, and I think all the students will benefit greatly from this.
Yeah.
Thank you.
Actually, I was working in Hyundai engineering company, and I had also the opportunity to go to South Korea for our works. I also worked there also for small duration of time. Yeah.
Yeah.
Actually, South Korea is quite developed, and those ideas, those who are executed there, Singapore tries to implement here also. And so that, for example, now we have the circular tunnel boring machines. Now here in Singapore, we have the rectangular tunnel boring machine, which we already implemented. So the technology-wise, it's very advanced, and it will be good opportunity for the students to know these aspects also, because we know only the circular tunnels and circular tunneling, but until I came to Singapore from India, I was not knowing what is the meaning of cavern. When I was working as assistant professor in MIT Pune, I was teaching the structural subjects. Then I joined here NTU as a researcher. Then I came across this Jurong Rock Cavern and work. It was a fantastic experience for me also. Yeah, thank you.
We can understand that because the way the concepts you have explained are so exciting. So definitely you would have found it very interesting to execute all these things.
Yes.
Very, very nice. Very nice.
Thank you, sir, Narayan sir. So now, yes, sir.
Yeah, maybe in the next seminar, maybe I will explain more about the Jurong Rock Cavern and then our this DTSS2 project. The thing is that the issue with me is that I cannot use the actual project site photos and information which is not in the public domain. That is a restriction on me. So only the material which I can share or show it to you is the material which is available in the public domain. Yeah, but the experience, yeah, definitely that I can share with you. Yeah, thank you.
Thank you.
Pravin sir, actually, it's a great moment for us. Actually, we planned it and it happened today. And really, I'm happy to introduce you to the world of students and faculties and all new cavern concept has been sharing to the student session so that they should have an awareness about all these new trends happening in the industry. That's what we that's what we are focused to, and really I'm happy for you because you took so much effort and time to spend for us in this evening in ahead of your busy schedules to share for our students. And he's again sharing one more session in our symposium, and really I'm so happy for you, sir, to be a part of the program. And in between us, Srikanth is put so much of effort to connect us both, and really
yes.
it's a great it's a great wonderful time for our students because all this happened for them on behalf of the student chapter. So
thank you.
I personally thank you, sir, for this moment to be here for for us actually for us to share this wonderful session of the new trends, variation in trends happening in the industry. So hope that our small students from including the faculties will be more benefited. I think some faculties are also there here. Grishma, are you there? Grishma? Grishma, are you there? I saw some faculties are there. If you want to share something, you can add. From S7 final years, anyone? Hello?
Yeah, generally the students are shy. Shy
yes,
from asking the questions. Yeah.
Actually, yes. They are very shy to speak, but I think almost they are very smart too. Some are that actually. Okay, so hope MEC can continue. Okay, thank you, sir, from my personal viewpoint.
Thank you very much for having me on this wonderful webinar. See you soon.
Thank you, sir. I hope the session is going on. Students have some more plans. So let them go with it. MEC, you can continue.
Okay. Yeah.
Thank you. So now, as a symbol of our love and gratitude, we would like to give a small token of appreciation to our special speaker, Mr. Pravin Muley, sir. The memento is right in front of your screen. This is presented to Engineer Pravin Muley with deep appreciation for your visionary guidance and in grateful recognition for your enduring commitment throughout this webinar. We thank you for spending your valuable time with us. Thank you, sir.
Thank you for your kind words and this appreciation. Thank you very much.
It gives me immense pleasure to convey that IGS Student Chapter of Marine Engineering College, with the support of TC202, is organizing a symposium and TSR lecture from 1st to 5th of December. Now, we are going to present a promo video of this event. We are expecting your valuable participation in the upcoming symposium and TSR lecture. Now, to officially propose the vote of thanks, I would like to call upon Nikita from S3.
A pleasant good evening to one and all. It's my privilege to have been asked to propose a vote of thanks on this occasion. I, on behalf of IGS Student Chapter, extend my sincere thanks and gratitude to the honorable delegates who blessed us with their presence and spent the valuable time with us. And also, I would like to express my sincere thanks to Pravin sir for his informative words. Your thoughts have enlightened our minds, and I'm damn sure that it will guide us to the right path, sir. I'm grateful to all the teachers and I wish hearty congratulations to all the participants for the active participation in this webinar. As no program can become successful with a single person, so I extend my big thanks to our entire organization team. Thank you.
Thank you, Nikita.
Thank you very much.
With this, we have now come to an end of today's session. Before we conclude, please make sure that you will fill the feedback form. The link for the feedback form has been provided in the chat box. The link will also be shared in the WhatsApp group. So, we are expecting your valuable participation for our upcoming webinars and symposium and TSR lecture. Thank you, everyone, and have a nice day.